Let us now continue our program, and it's my great pleasure actually to invite the keynote speaker, Mike Wood. So Mike has many hats, including being actually the vice chairman of Working Party 1 in Study Group 5. He works for Telstra, and well, I will not spend any more words and just give Mike a chance to tell us about more.
Okay. Thank you. And keeping in line, excuse me, keeping in line with the theme, I will put this on so that we. Okay, is the remote clear? So, ladies and gentlemen, distinguished guests and members of the Polish government and the ITU, thank you for inviting an Australian to Poland to give the opening and the keynote address. It's truly an honour to represent the ITU, the IEC and the other hats that Christina was mentioning. And it's somewhat strange being in the Northern Hemisphere in winter for me, because leading up to Christmas it's normally hot. We're at the beach. It feels warm in this room. I like the flowers that were on the screen. And I went to my first Christmas market on the weekend, and I couldn't work out why everyone was buying these red cups. And then I realised they were drinking the hot wine and the schnapps. And I tried that, and it was fantastic, because Christmas for us is about being warm, but we still do the roast dinner. So we have the air conditioner fighting the oven. So that's what I'm returning home to after this presentation. So this morning, if I get this... Oh. Whoops, I've gone the wrong way. Okay. What will we talk about today? What I'd like to do to start with is just to give you an overview, and we've seen a couple of slides already about what is 5G and to set the scene. But my the main purpose of the presentation is to look at the benefits, the challenges, opportunities, and what is a responsible framework for the deployment of 5G. But to do that effectively, I think we need to set the scene. So that's what I'll do to start with. Now, what is 5G? Many of you here will know the history of mobile networks. For some that don't, typically every decade there is a new G, starting with 1G in the 80s. Now, I've had the privilege of being involved in the deployment of most of these technologies. And I thought what I would do for the opening slide is just put up a picture of the different types of phones that were available with these technologies. And I don't know which one you first started with or which one you owned. I think I can safely say I've used most of these. And the very first one was certainly quite heavy. It was heavy in terms of how much you had to pay, the bill to use it, and the weight. And of course, as you progress through the decades, the phones got smaller and smaller, and then very small. And then they've got a little bit bigger because we have the smartphones and the screens. So I wonder where your first phone or what your favourite phone was on that screen. And of course, as we head towards 2020, maybe a little bit earlier, as we've just heard, the first applications are likely to be fixed wireless. We will have to wait and see what the types of devices are that you can buy in the shop. But certainly over this journey we've seen SMS, and I think it's the 25th year, I read, of the first SMS. And it seems that, and I think at the start they thought, will this application work? And it's been one of the most popular applications still to date. We've then moved on to the first mobile internet, enhanced mobile broadband for 4G, and of course 5G is going to open up a world of new opportunities. So I won't touch on all of these, but the technical specifications that have been given to the teams doing the research and setting the standards are quite outstanding, really. A couple of the important ones, and I think that was mentioned earlier, the user rate. We are going to see much faster connections, much faster data services, and of course you can talk about peak speeds of 20 gigabytes per second. But what will that mean to the user? And I think we heard just before it's likely to be around the 1 gigabyte. Now we have a network running in Australia at the moment on a modem that you can use where you can get between 900 to 1 gigabit over the air on 4G LTE networks. Now, admittedly, that's not a fully loaded network, but that's the user experience when you've got the wide bandwidth, and that will grow, and that will become the norm that people expect. Using low latency applications, that is going to be one of the differentiating factors of 5G that will open up a whole range of possibilities for people. And one that I thought that was in here that was very interesting was the being able to use it at high speeds on a train. Now, I can imagine that will be very popular in Europe, being able to use 5G and fast internet services on a train. I'll get this right in a minute. So why 5G? Now, really, communities have grown up and they love smartphones, they love the data connectivity, and they do more and more and more, and they want more. So if we look at the start, we're using far more data, but basically the networks are almost full. We need to grow and expand the networks to cater for that data use. And it's going to, the digitization is going to enable various opportunities and new industry sectors that we haven't thought about today. So there is going to open up a world of new opportunities. And I keep getting these slides wrong, so I do apologize. So in terms of connecting the community, what have we got here? So 5G, as we talked about before, if you look at a community that's built up of people where they live, where they work, where they go to school, the medical applications that we talked about, 5G is going to be one of those enabling technologies that really helps to connect people. And we've sort of got a term here that it will enable the connectivity of today's modern society, the Internet of Things, and tomorrow's innovations. And that's really what we're looking at. What will it be like for the people of tomorrow? And one of the most important things to look at here and to remember is that the connectivity is all done via radio waves. Now, the radio waves that we're using for 5G and the technology for 5G in terms of the actual modulation schemes are very similar to 4G. So we're not using anything different. The cloud computing and the core network will change considerably to cater for this, and we'll talk about that shortly. So in terms of opportunities, one of the ones that I think I'm most excited about is the opportunity for healthcare. If you think about a country like Australia, or in fact in many European countries where you've got remote connections, and one of the concepts we're looking at is the connected ambulance. In those critical situations where you can do diagnostics and you can be in touch with medical centres and specialists and do that pre-diagnosis, that can be the difference between saving a life and not saving a life. And that early diagnosis and that early intervention can be critical. In a country like Australia, where you've got many medical specialists spread out through the community, for them to be able to connect up over high-speed, reliable links, no matter where they are, that will be critical. So that's going to open up a world of opportunities. But of course, if you think about education, smart cars, and autonomous driving, just improving vehicle safety and vehicle-to-vehicle communications will be very important as well. So one of the things that in Australia, one of the things that we're very excited about is the possibility of smart farming. So remote agriculture, I mean, most farmers today probably won't know what smart farming is or what IoT applications are. But our group managing director in Singapore earlier this year said that in 5 years, every farmer in Australia will know what a smart farm is. It'll be just given that it's connected. But if you think about everything on a farm that can be physically connected through an IoT sensor and have a radio connection, and a lot of the farming is then monitored through the data analysis, that will make a huge difference in sustainable farming. And that's one of the applications that we're really looking forward to. Now, I think this is a mandatory slide that every ITU presentation must have. So I thought I had to put this one in, and we've already heard it talked about before, so I'll move on. But it really shows the three corners: the ultra-reliable, low-latency communications, the massive machine-to-machine, and of course at the very top, the enhanced mobile broadband. So I think this was one of the requirements of a presentation, that you must put this ITU slide in, but it is a good reference. So how does 5G work? Now, this is really important when we talk about EMF. The first release of 5G, and the standards are still being finalised, we'll talk about them in a minute, is 5G will work in conjunction with 4G. So that's a really important concept. They won't be a non-standalone network to start with. So if you look at this slide here, 4G with the macro cells that we have today is going to provide the backbone for most networks. It will do the controlling. It will have the control signalling for the first 5G connected networks. On the bottom half of the picture, you've got a variety of 5G macro cells and 5G small cells. So what will happen is the control signalling will occur over the 4G plane or the 4G layer when you need to make a connection, and it will then choose what connection do you need. Do you need to do very fast data? Do you need a high reliability connection? And the data will be either transmitted over the 5G layer or a combination of the 5G and 4G layer. So 5G will be very dependent on 4G when it's first rolled out. And this is what's known as a non-standalone network. Later on in later releases, 5G will operate as a standalone network by itself, but it is important to know that it will be working in conjunction with 4G. We heard about the spectrum before. Now, there are three main areas that we need to look at here. Now, we talked about macrocells and small cells. There'll be a release of new spectrum below 1 gigahertz, and that will be reusing some of the LTE bands that we have today, some of the bands that we use for 4G and 3G, and that will typically be in the 600 to 700 megahertz band. We will be using somewhere of the order of 3.5 to 3.6 gigahertz. So the low end, and I'm not sure where the pointer is. No, I've got the wrong one. Sorry about that. I realised that now. But I've gone way too... And I don't know how to go back. I'm not sure if... Yes, that's what I wanted to do. Okay, so on the far left-hand side, you've got the macro cells, and that will use the frequencies of 1 gigahertz and below. In the middle, you've got a mixture of macro and small cells, and that will typically use the 3.5 gigahertz band. So that will be one of the first bands that's deployed. And then we talk about millimetre waves. Well, technically, millimetre waves start at 30 gigahertz and above. But one of the first applications of 5G will use the 26 to 28 gigahertz band. And typically we will see small cells and many small cells for that band, and that will cater for extra capacity and extreme data rates. So that was the small cells at the top, the macro and small cells in the middle, and the macro cells below. So in terms of the architecture, I talked about 4G and 5G working together. So what you have here is, and I've done it again. Yes, there. So here we have a 4G macro cell, very close. We've got a little shopping strip with some outdoor cafes and some shops, and they will be served by a mixture of 4G and 5G small cells. So if you can think about wherever you need the data application, wherever you need connectivity, you're going to have a range of the macro coverage by 4G and the small cell coverage by 5G. And this is the same right through the community. So you may have macro cells in the countryside, but you will still have a range of 5G facilities to provide that very fast data application. The big change that you'll see will be in the core network and how the data is connected. We're going to see core networks use distributed networks, and one of the ways you can get very fast data and very reliable communications is that a lot of the core and a lot of the content will be pushed to remote servers. So if you think about movies and applications that you might want to watch online or content that you want to download, they will be in fact housed on local servers close to where the users are. That's how you will get one of the higher speed connectivities and the faster down rates. The other thing that's changing on the radio access network is they're building the antennas and the transmitters all into the same box. So they're removing a lot of the time delay components in the radio network so that you've then got a very fast radio connection and a very fast data connection. That's why you split the control and the radio paths depending on the network configuration. So the technologies that will be really used by 5G consist of conventional antennas, which are the multiple input, multiple output antennas we have today in the 4G networks, the advanced antennas that were mentioned before with the beam steering, small cells and millimetre waves. So the massive MIMO antennas, if you think about, whoops, I've done it again. If you think about the Macrocell that we have today, typically that's a cell that's spread over 3 sectors. In a 5G world, a 5G Macrocell will consist of smaller antennas, but more than 100 elements per antenna. And what the elements do is they form an electrically steered antenna, so that instead of one sector spreading out over 120 degrees, you can divide that sector into multiple beams. And not all of those beams transmit at once. It only depends where the user is as to which beam you need to connect to. So an application of that is in this picture. So what we have is we have a Macrocell today, which is like the 4G network today, where you've got one signal that covers everybody. Moving to a 5G Macrocell, where you can split that sector up into potentially over 100 different elements or multiple beams, you will only connect to the beam that you need to access for service. And that's a very important factor, because when you don't need to transmit in a certain direction, the network won't transmit in that direction. That saves power, that saves interference, and with lower interference you get better connectivity and lower EMF. So it's not that the beams are going to point at you and track you, it's as you move around you will connect to the one that is serving your particular area. And they will work in the vertical mode as well as the horizontal mode. So that's one of the good features of the 5G design. We talked about the new spectrum. You can't add the capacity without adding spectrum. So if you add the spectrum, you've then got the ability to use that for your higher data rates and your higher connectivity. I talked about small cells before. These will be a very important factor for 5G networks. The more we want to connect and the more reliable connectivity we want, you will need a short path or a short way of connecting to the network. Small cells will deliver that for you. They are low-powered, physically small infrastructure that connect to the nearest central server. And they will also work with the Macrocell. So the combination of small cell and Macrocell will deliver the best type of network. In terms of the timeline, 5G development started many, many years ago, but the real research and the concerted effort was really around 2012. And as you can see, we're in 2017. The first of the 5G standards will be finalised actually in December, the first non-standalone, and we're talking about the first standalone networks towards the end of 2018. Many of us are doing trials, and we heard before the first official trial will be in next year, I think in February. But next year will be the first release of the standards as well, so that commercial operators can confidently build networks for the first to the first 3GPP standards. So what does it mean for EMF? Now this is really why we're here today. So in setting the scene, what we have is the technology uses radio frequency transmissions like many other services that we have today. It's a significant evolution of 4G. If we don't go to 5G, we will have congested networks and we won't make use of the technology. The typical levels from networks will remain low, and in every, this is one of the reasons that if people want to use more devices, they want more connectivity, and it's a bit like going from records to cassette tapes to CDs to DVDs. The technology evolves. We can use more data in a smaller area. It's the same with radio. We can actually reduce the background levels by going to this newer technology. The devices, they're going to become very efficient, because the way this all works is that if you want to have the lowest EMF and the best connectivity, you actually want the device to transmit at the lowest power level for the shortest possible time to make the connection. And that reduces the EMF. And overall, the networks, if we look at the key points here, the networks will be very efficient, and the EMF in the public areas will be far below safety standards as we have today, but we've got to make sure that we design the networks correct to do that. We've got to employ the technology and build the correct combination of small cells and macro cells. Now, some of the areas that we're working on, the compliance zone evaluation. When you build a facility and you've got to do your compliance assessment, typically in the early versions of 2G, 3G and 4G, we were doing worst case power assessments. We know in reality that's not the case now. With the advanced LTE networks and 5G networks, they don't run at full power. So we've got to do assessments at realistic power. And that will be a key thing that you'll hear later on today. In terms of research, people often... That was my 20 minutes. I haven't got very much longer to go. Then we'll have some questions. Even my 5G phone is catching up to me. People often ask, has there been any research in the millimetre wave band? This is all new. My very first job was in the Navy working on radar and satellite systems. We were working with, equivalent millimetre wave frequencies many, many years ago. There has been a lot of research because in the military and in the early days, that was one of the areas that was researched the most. When I looked up how much has actually been done, there are many published articles that WHO linked to on their website. In fact, there's over 25,000 scientific articles on EMF and about 2,500 on mobile communications alone. On millimetre waves, when I did the search the other week, there's over 350 articles just published on millimetre wave and safety research. So it's not that it's brand new. We have been doing, there is quite a bit that's there. And the established science that we'll hear later, so far, with the guidelines that look at the science, if we apply the guidelines as they are today, there are no known health effects at or below the guidelines. And we'll hear more on that today. But I'm reassured by the actual studies that have been done. But there are many health experts that will talk about that a little bit later this morning. In terms of the challenges, we heard a little bit about this, but I think this is really important. Explaining 5G to stakeholders is critical because people think it's new and, well, the technology is new, but you need to explain it carefully and have good resources. Globally harmonized EMF standards, whether it be exposure limits or testing methods, are also very important because we work with a global technology, and to get the most efficient networks, and remember keeping EMF levels low, you do need to work to globally harmonized standards. There will be additional infrastructure, and that's always a challenge. Whether it's a macro cell or putting a small cell in a community, there are challenges there. And that's the last point I was saying. Deployment of small cells, it's going to be vital to keep people connected, and they want that, but you've got to do the deployment in a very sensitive way. What are the opportunities? So if you turn this around, I think the opportunities for governments and operators and stakeholders are that we can have harmonised limits. And if we do that, we can make sure that we've got global companies designing the equipment. When we deploy that equipment, we can ensure that we do get the lowest possible transmitted power and the most efficient networks. One that I'm really big on is the proactive stakeholder information. You can't just deploy new technology without taking people on the journey with you. And this is one of the reasons that events like this are so important. Whether it's in Poland, in Australia, in the UK, in South America, different communities have different questions, and it's really important to take them on the journey and have good information to share. And what the other really important thing is that we're delivering enhanced mobile technologies. And, you know, whilst maintaining low levels of EMF is very important, we can do that with this new technology and keep it low. What's a responsible framework? I've often been asked by different governments and different sectors, if you were starting from fresh, what would you do? So the first thing, and I've mentioned this before, is harmonised standards. And I'm talking about exposure limits and testing methods, because it's no good having different testing methods, you get different results. And that's where the ITU and the other standards organisations come in. We have harmonised test standards. Responsible deployment is very important. It's no good having operators that just go and put stuff everywhere without taking the community and respecting the local deployment rights. But also you've got to have the spectrum, And governments and regulators need to have an environment where it's done sensibly and in a coordinated manner. And it's also responsible, the operators and carriers must be responsible in their deployment as well. And I've mentioned before stakeholder engagement. Now on the right-hand side here, we have some excellent resources in terms of standards from the IEC, ITU, IEEE, and we're going to hear a bit about ICNIRP shortly. In terms of the ITU, we have the Smart City Guide that gives a number of really good points on responsible network deployment, and that's available online now. As was mentioned before, the ITU also have an online mobile app called the EMF Guide. It's in 6 languages now, I believe. One of our activities is to update the app with 5G. A lot of these pictures that you've seen will be in fact available on the app when we do it. We've been designing the illustrations and graphics, and the GSMA recently has also published a GSMA 5G and EMF guide, so that's also available now. And it stopped working. So my conclusions. 5G will unlock significant benefits for the community, and the community is asking that of us, and they're asking us to do it in a responsible manner. It will keep EMF levels low, and it will certainly keep them well below safety standards. Harmonized exposure standards are recommended, and you've seen that a few times in my presentation for the reasons that we've talked about. If we have non-harmonized standards, politically, that can sometimes win a couple of points, but what that means is that you've actually got networks that aren't working as efficient, and you're not getting the full benefit. And a responsible framework and effective community consultation is probably the best way to do this. I had an experience in Sydney many years ago where a local government said, when you roll out 3G, we're going to have special limits for 3G because we're going to keep our citizens safe. So they did that. They introduced lower limits. And then when they went and analysed their network, all of the mobile networks passed the new test, but all of the council and emergency services and fire brigade and all of the other networks did not pass. So that meant they had to turn them off. So they rang up and they said, we've got a problem. We've just introduced this new rule, but in fact, you can keep using yours, but we have to turn all of ours off. What should we do? And I said, you probably should have a look at the rule because we're not following harmonised standards. So my closing message is if we can do this cooperatively with industry, government and stakeholders, it will be a very effective rollout. So with that, I thank you and I'm happy to take questions. And the 5G device has stopped. So with that, do we have time for questions, Christina? We do have time for questions. So I'm happy to take any questions.
Maybe I can start. Yeah, it does. Jafar Keshvari from Balta University and Huawei Technologies. So, you show very nice pictures related to the applications or possible applications. How much of those figures are science fiction and how much you think that would be or is becoming a reality?
Science fiction versus reality. I think reality leads, is if we don't have science fiction, we don't have a vision, we don't have an aim. Okay, so we are running experimental networks now. And the pictures show, what we're trying to show is graphically an easy way to communicate the concepts. So a lot of the pictures are done in a style that makes communicating quite easy. I looked at a lot of online presentations and you know what, they were very, very complicated, very hard to tell a story. If I look at our own test network, and similar to what's happening in the Winter Olympics, we have devices that are running at 5 to 10 gigabits per second now. So we have mobile devices, and they can drive around. We have the very high throughput. We have the low latency working. So it's now about bringing on the journey the industries and the applications. When we talked to the emergency service operators in Australia about the connected ambulance. And they've got mobiles now, but they drive along and the speeds are quite low because the networks, and they said, if we could do this, hey, you're opening up a whole new world of opportunities. So it's really the vision. What can you vision and what can you design and what can you bring to... I work on this concept of vision to reality. So I think the reality, the vision is endless, but the reality is it will take some time to have all of these connected devices. But if I look at all the different Gs, 1G, 2G, 3G, 4G, and now 5G, this is the one that's probably got the biggest promise because we can see it happening now. In terms of the Olympics, we were looking at how could you do some test cases. Now, we were wondering whether any of the runners would wear something that was 5G connected. And someone said you might have to choose a runner that doesn't think they're going to win. Because are they going to wear something else? But you know, when the bodysuits come out and when you can have something that's fully integrated into your running kit or your swimming or whatever, I think the helmets that they're going to use in the downhill skiing will be amazing to watch next year. But we are on this journey. The farmers, we already have connected farms, and the ones that have adopted the technology are reaping the benefits because they can see every tree, every crop, and they can track that. So, and we have some vineyards in Australia that are using, and they're my favourite. So, good question. Do we have any other questions? There's a question here.
Jerzy Żurek, National Institute of Telecommunications, Poland. You mentioned EMF levels harmonization. We have a problem with this harmonization here in Europe. Do you have any idea of activities, global activities, which should be done to harmonize it?
Well, these sorts of events are a classic case of you know, sharing information and sharing knowledge. We're going to hear shortly from ICNIRP, the International Commission, on their review of the EMF limits. Of course, individual countries, they choose limits and they have policies that suit their country and suit their democracy and their people. I think it really comes back to this balance between what is real. I think we heard before about let's from Poland. We heard let's talk about the facts. Let's establish what the facts are, and then the facts should help us drive policy. But that's often hard when you've got emotional and people wanting other factors. In Australia, we follow the ICNIRP limits. Our government asked us, because I know in Brussels, at the head of the EU, they have the most restrictive limits. And you'd think, and for many years I would go to Brussels to meetings and my phone would go from 4G back to 3G and then I'd be on 2G. There'd be no 4G. And someone said, what would happen in Sydney if we did the same thing? Because in Europe they must be onto something if they've got something that's working better. And I said, I don't actually think that's the case. So we modelled what would happen in Sydney if we adopted the Brussels limits. We would have to turn off half the base stations. So we have about nearly 1,000 sites in Sydney. We would have to turn off 500. And that means we would have to build twice the number of smaller base stations. So we asked the community citizens group, this is what they're doing in Brussels. That's a great idea, but we'd need to build twice the number of sites to keep you connected. And they said, oh no, we don't want that. So I think it's a case of let's look at the facts, let's share the information. And in terms of global initiatives, the GSMA, the Global Operators Association, the Global Manufacturers Association, and the global standards groups are the best groups to talk with local communities and and work with local governments and work with and be part of that conversation, because it's about bringing them on the journey. And you've really got to make the right choice for, and it's not our position to tell which governments what they must do, but I think it's our to share the vision and to show how that in this case, if you deploy 5G and you do apply the ICNIRP limits or harmonized limits, you will actually get the better connection. And when you do that, you will drive the EMF levels lower. And we'll hear some presentations later that actually show that experience. But that's a really good question. It's a difficult one because you're mixing politics, emotion, and science together. Do we have any other questions? There's one down the back. If you find the answer, by the way, let me know, because...
Mirek Słomiński, Warsaw University of Technology. Could you please explain 5 years needed to move from 2020? So that means the first commercial deployment of 5G to 2025 massive deployment. What is for 5 years to be spent?
So I think your question was, what's the different, the first commercial deployments are listed for 2020 and the mass deployments in 2025? That was your question? If you watch the media and you watch all of the announcements, you would think that we already have 5G today because there's lots of people talking about 5G. I think you'll see the first commercial deployments towards the end of 2018 and start of 2019 in small areas because the actual standards for the network equipment from the 3GPP organisation are only just being finalised now. So the vendors and the equipment manufacturers have to take these final radio engineering standards and convert that into equipment. The trials will occur in early 2018 and that will really test the technology. So in 2019, you're likely to see the first devices, and as was mentioned earlier, the first devices are likely to be fixed wireless, so black boxes that sit on a table that connect up to basically give you high-speed wireless internet access. And I know in the US, they're looking at that deployment in 2018. To go from the first of these connections to mass market where everything can be connected by a 5G device, that will take some time. So over the 2020 to 2025 period, you'll see chipset vendors and manufacturers building these devices to suit the market. You won't be able to walk into a shop in 2019 and say, I want that 5G phone or this one. There might be one phone, but it'll take that period of time. But also because you've got the industrial sectors that go, hey, there's a lot we can do with this, there'll be a whole lot of applications that we haven't even thought of that can use this low latency communications. And I was part of a group looking at connected cars and smart road infrastructure earlier this year. And we were looking at when will motorways prevent the old cars of 2020 from going on them and only have new vehicles from 2030. So will there be a freeway that says stop? If you've got a connected car, you can use this freeway. If you haven't, you can't. And the challenge we gave to some students was we were in the year 2030 and the older models of cars, you know, the old ones are from 2020, they're not allowed on this freeway. So I think you're going to see that generation, that's where the time will be taken. But then you need the standards and you need the expertise like is in this room to deliver that. I think we're probably up to coffee break. There is one more question.
Thank you, excuse me. My name is Wojciech Halka from the National Institute of Telecom. My question is about what do you think about the fixed network deployment in the light of 5G? You mentioned that, well, there will be many small cells. So will they be connected via the fixed or the radio fixed? How, cable or radio? This is my question, in fact. How you see this? Because it's few information about this aspect of the 5G development.
It's a sensitive topic in many countries because you're rolling out fixed infrastructure that has optical fibre or connections back to the core network. A lot of this depends on how do you get from the point, the fixed point, back to the internet. If that's a wireless connection, you've got a capacity issue, or you've got to manage the capacity. So if I use the experience in Australia, our 4G networks are running much faster than our fixed networks at the moment. And our 5G networks will be exceptionally fast. But if we turned off the fixed network, everything would slow down because you haven't got the capacity. So this is where the engineering comes in. You've got to do a balance and you've got to really design it so that I think one of the best applications of small cells will be, people get concerned when you call them mobile towers or base stations. If you had a community connection point, in other words, a small cell in your street, most people would love, oh, I want a community connection point. I want to connect, like your Wi-Fi point. They'd love that. do I want a base station? I don't want a base station. I want a community connection point. If that was a 5G small cell, and then some of them would be by radio and some would be by optical fibre, it's that mixture. And it really depends on the country that you're in. In outback Australia, a lot of our connections are by radio, and by satellite. But in the cities where you need all of the hospitals, the schools, and the infrastructure connected by optical fibre, that's a vital piece of infrastructure. But it'll be, and I think you mentioned earlier, Dr. Lee, that it'll be this combination. One of the challenges for marketing people, they always like to have on the phone the latest tech. You're on 5G. And if you think about the hybrid connection between 4G and 5G, people will go, I don't want 4G, I only want 5G. But hey, the phone's working fantastic. It's that combination of wherever you go, you want an always on, always connected. And that's where the engineers and the policymakers come in. Because if you've got the right policy, the right engineering, you'll get the best connectivity. And then what we're here to talk about today is EMF, and you actually get the lowest EMF. So that might be a good point for our coffee break. So I thank you, ladies and gentlemen.
Many thanks, Mike.